So difference between the traditional engineering and modern design with DFX. So in this video, we will going to discuss about the small things, which is whatever we have here. So what is traditional engineering? Point number 1, considers functional requirement. So then the second part is addresses other aspects after design freeze. Then, and the next point is iterative in nature. That is in the traditional engineering. Then the point number 4, heavy usage of tools. That is normally the traditional engineering. That means the conventional engineering what we follow. Use CAD tools. And then the responsibility over the design. So you are solely responsible over the design. But when it comes to design with DFX, as the functional requirement considers the functional requirements in traditional engineering, here it is the life cycle requirement. Consider life cycle requirements. So point number 2, as early as possible, they address other aspects of the design phase. It will be done as early as possible. So in the third one is, in the traditional engineering, it is iterative in nature, but here it is one time right. So here in the fourth one, heavy usage of tools in the traditional engineering, but here we use heavy usage of system, because design for X, because we are considering for design for manufacturing, design for assembly and all those things. So we need to have the computerization is a computerization of tools. That means you are using the CNC and all those things, which are going to be heavy tools. And point number 5, depends knowledge-based systems. And point number 6, responsibility over the whole life cycle. That means it is the responsibility over the design here in the traditional engineering, but here it for the entire cycle, the responsibility will going to lie on them. Then when it comes to the design central development model, the design methodology dictates that there is a higher level of design analysis required at the front end of the process. This does not necessarily involve the participation of members of the other departments, but consideration of other departments, but consideration of their requirements is embedded in the activity within the detailed design. So that means their other departments' involvement will not be there, but it will be embedded within the detailed design. Downstream design changes are minimized. That means down the line, once the conceptual design is approved, then once it goes for the detailed drawing, so where the downstream design, that is the downstream design means wherein once the conceptual design and the design is approved, then only the next part will going to be the detailed design or the detailed drawing, which will going to be done. So at that stage, there will not be any changes. It will not going to be allowed to make such any changes in the conceptual design. So all those things which will going to be minimized when it comes to the downstream design. For example, the production process here still takes place after the detailed design has been completed, and overall the process still predominantly sequential. The design-centered model thus demonstrates the front-end fixing of the design, though the use of design for life cycle tools and techniques. So here we have the design-centered model, wherein we have the design for X, wherein we have the concept of design, detailed design and analysis here on the one side, that is the front end. Then we have the prototype, then testing and production ramp up. As the design is finalized, so this part will going to be the production part, and this will going to be the product design part. So this is how the design-centered model will going to work. In the design-centered model, the central piece of information is the original detailed design, which may be in the form of 2D or 3D CAD models and remain throughout the development cycle, acting as the master to which all the processes have to comply. So that means this is the central part of the 2D or 3D CAD models will going to play a major role, and each of the departments will going to take the same model and try to analyze, and each department will going to take the same model for the manufacturing. So the required tools and technologies here are centered around various analysis tools such as FEA. Design for manufacturing also takes the same model. Design for assembly also takes the same model. Design for environmental, and again they will going to take the same model. For environment means we are talking about the material here. Life cycle costing, for costing also they will going to take the same model. So this is how the design centered model will going to play a major role. And of course, there are a lot of other activities to be considered. The change control process is the same as the sequential model, in that the master model requires modification to enable engineering change to occur. So that means whatever the changes which we need to be done, it has to be done at the master model. Then all the other things which will going to be updated simultaneously. The premise of design-centered product definition is that at each stage risk is minimized before release. So at every stage the screening will going to be takes place. So thereby the risk is minimized before the release. Design-centered approach is employed particularly by automotive and aerospace industries or aerospace companies, with the driving forces being predominantly based on quality and cost of product development. So basically, when you are going for the design-centered approach, we are predominantly more concentrating on the product quality and also on the cost effectiveness of the product development. Strategies for recovery at the end of product life. So what are all the strategies required for recovery of the at the end of the product life? What is the product life? The ultimate goal for product recovery is to retrieve a product's inherent value when the product no longer fulfills the user's desired needs. So the product recovery has to be taken place. Suppose if some parts have been getting worn out, we have to replace it. So we have to take back that product inherent. So that means when you have in the warranty period, if it is just lost the product life cycle, then we have to take it back and we have to try to analyze this. Product recovery is a major contributor for implementing sustainable design business practices that can result in savings in energy, possible emissions, and costs relative to the process of producing the parts and in the volume of virgin material. Many companies implement product recovery management or waste management programs to recover products and or its components, thereby eliminating waste and increasing profits. The strategies to be followed for the recovery of resources at the product's end of life can be grouped on different recovery levels. One is the reuse, that is product reuse. It refers to the process of disassembling products to recover usable parts and assemblies for the purpose of utilizing them in newly manufactured products. Then, components that have not undergone excessive deterioration during use and which guarantees the functional standards and optimum working conditions can be recovered as components for reassembly. That means when we have the total assembly, in some of the parts are still can be used based on their functional requirement, and it is possible to still, if they can use, they can also recover those components and they can be used for the reassembly. Remanufacturing, it refers to returning a used product via a manufacturing type or intermediate process to at least its original performance or specifications with a warranty that is equivalent or better than that of the newly manufactured products. It is a process of recapturing the value added to the material when a product was first manufactured. So then reconditioning or refurbishing. It is a process of returning a used product to a satisfactory working condition that may be inferior to the original specification. So that means we will be able to recondition the product so that which can satisfactorily satisfies the working condition that may be inferior to original specification. Then recycling, that is the materials what we will going to use it for recycling. It refers to the process by which the product materials destined for disposal are collected and processed and manufactured into a new product. It is reusable products. So the materials of parts that cannot be reused and composed of recyclable and compatible materials can be recycled by the recovery processes included in the material's own life cycles, or they can be treated and used in external production cycles to manufacture products with less stringent material property requirements. So what are the factors promoting the product recovery? So what are the factors required for promoting product recovery? Increasing environmental consciousness of society and pressure from NGOs, consumers, business partners, and suppliers. So naturally, environmental will also play a major role, because the product which will going to be developed on the material may have some impact on the environment. So NGOs will going to come into the picture in such cases. Consumers, the consumer is the customer who will going to consume the product. Of course, having the business partners and suppliers also. Increasing number of environmental regulations and legislations. Periodically, the environmental regulations will be implemented by the government, so which can take care the requirement of the environmental standards. There should not be any hazardous materials can be used in the product development, so that it will going to have a direct impact on the environment. Minimize the amount of waste sent to land or disposal, thereby preventing environmental pollution. So that means after the product has been lost its life, we need to dispose the waste. So that waste should be disposed it should be disposable in a proper and a systematic way. So they cannot dispose the material then and there itself, and thereby having a direct impact on the environment. Possible savings in energy consumption and cost, which in turn adds profit to the company. Organizations' own social responsibility, principles and targets that add value to themselves. Obviously, because organizations should have their own social responsibility, and also they should have some principles and targets that add value to themselves. So product recycling, the various benefits of product recycling are: number one, recycling saves energy. Making products from recycling materials results in energy savings, because more energy is required to extract, refine, transport and process raw materials to the desired shape, size and finish. So recycling saves energy. So that means whatever the product which has been already developed and it is worn out, then we are going to take the same product and recycle them for your use. So this will helps in saving the energy, because more energy is required for extract. So extract means producing, refine, that is it's a raw. So you need to, that is the crude, then it becomes to refine that, and also transport has to be takes place from one location to the other location, and process the raw materials to the desired shape and size. So it takes more energy. So then this also means that more time and cost are involved for making product with raw materials, and overall recycling saves energy, time and money for making products. Recycling saves natural resources also, because the conventional natural resources have been utilized more when you want to extract. So recycling helps in conserving natural resources by minimizing the extraction of fresh raw materials from the earth through mining and forestry. That means you are breaking the trees, or cutting the trees are also minimized. Recycling helps protect the environment, since we are destroying the trees, so naturally the environment will going to be gets imbalanced. So recycling reduces the amount of waste sent to landfills, and incinerations reduces substantial air and water pollution resulting from extracting raw materials, that is mining and quarrying, and reduces greenhouse gas emissions, thereby protecting the natural environment and sustaining the planet for future generations. So that means so waste normally is landfills. That means they will going to fill it in the land and then going to bury that. So that can be avoided. And substantial air and water pollution. Sometimes the industrial waste is given to the sea. So thereby the water will going to be get polluted. So that can be minimized, and reduces greenhouse gas emissions, thereby protecting the natural environment and sustaining the planet for future generations. Recycling can generate more revenues. So by doing the recycling, slight cost saving from the recycling helps to reduce the product cost, obviously, and which in turn attracts more consumers, generating more revenues to the company and having an edge over the other competitors. Because of the cost, what happens? More revenue will going to become come to the company, because the more customers will going to be attracted because of the competitive rate. So thereby we will going to generate the more revenues. Recycling enhances business reputation. So once the quality you have been ensured, so you are going to get the better business. So possibilities regarding attracting new customers, enhancing chances of winning contracts, and improving customer loyalty by demonstrating the company's environmental responsibility. So that means you have to highlight what are all the benefits you have when your product has to be utilized, because on the environmental aspect, that means the component which have been produced will not have any direct impact on the environment. If you are able to highlight that, so then naturally the more customers will going to be attracted towards your product. can be met through recycling efforts. Business reputation thereby can be enhanced. Then what are in the next video we will going to discuss about what are the human factors in the product design. Thank you.